Great. Thank you, Brandon. All right, so as Brandon said, we've got the next 2 hours here. So this first hour, I will give an overview and updates for our Aero-structural Studio software. And if for those of you not familiar with Aero-structural Studio, it's our physics-based weight prediction downstream analysis tool of VSP. And we will discuss the workflow and some of that here momentarily. After that, Thomas Nishinzi will discuss really some new kind of exciting updates for the tool, which we're calling our sketch point layout tool inside of Structure Studio. And then in the second hour, Thomas will continue to give an overview of our sketch model UI capabilities. And then lastly, Joe Robinson will finish up with a UAM demonstration of a side-by-side helicopter. Okay, so let's get started. Okay, so for my talk, I'm gonna give the overview of Structure Studio. I'm gonna walk you through the workflow, the typical workflow for a user, and then also discuss kind of briefly our capability summary, highlight some of the selected applications, and discuss recent developments and some future work. Okay, so when we think about developing structural models and doing physics-based weight prediction, you know, the motivation or driving kind of force for this is basically because we don't have necessarily all the data we need to come up with these really nice empirical relationships that predict weight, like Nicolai or the Raymer equations and whatnot, especially when we deal with unconventional vehicles. So the idea is for these unconventional vehicle designs, we can start with a concept in geometry, say in OpenVSP, and proceed down a workflow where we're laying out kind of in this stepping stone image shown on the right here, kind of through the process of constructing the structural layout, developing the FEM mesh, the aerodynamic panels for loads and boundary conditions, you know, your materials, all the things that you need to actually size an unconventional vehicle. And so Structure Studio really has been in development over the last 15 years, and I've been leading the team probably over the last 7 or 8 years now. And we've done a lot of work with OpenVSP, and we think it's an excellent geometry modeling tool that allows for acceleration of this kind of conceptual design level weight prediction capability. So now I'm going to discuss the workflow for Aero-structural Studio. So as you can see at the top here, going across the horizontal, we've got kind of 6 boxes there, and we start at the left with our sketch point layout component. And this has been completely overhauled. I don't want to steal Thomas's thunder, but I will say that for those of you that were following our work and the Structure Studio toolset in the past, you would have noticed that we were doing a lot of development inside of our customized version of VSP. And now we are no longer doing that. We are using the Python API from OpenVSP, and we've fully integrated that within our workflow and our software now. It has a number of advantages for doing that, but I won't steal Thomas's thunder, so he can talk to that a little bit in the next talk. But this is the first step. So the first step is laying these what we call sketch points or structural hard points on your vehicle components that you've created in VSP. And for each of the components that you want to actually generate structural representations for. And so in this step, we also have capabilities for doing automated layouts, including automated wing layouts and automated fuselage layouts. And those essentially allow the user to very rapidly kind of have a predefined template for laying out their wing and fuselage structures. And as kind of we like to think of it as more of a starting point to really get into the details, but it allows you kind of to get up to speed and kind of create those very rapid layouts. The next step is what we call sketch. And this is a very detailed step involved in the workflow where you're going to go through and you're going to assign all the material properties. You're going to identify all the structural components in addition to any that were defined during your automated wing layout or fuselage layout usage. And then in addition to that, this is also where you're going to detail the analysis cases or the jobs that will be run for your optimization routine. And in addition, you will also define, any attachments and things like that that will essentially allow you to build up your sketch for each component that you're interested in modeling structure for and connecting it together into a final kind of complete vehicle FIM. So once you've done that, the next step is really we've kind of combined these next two blocks here, what we call FIM and merge. And this is essentially where the software will go on and take all the information that you defined in SPL and Sketch, and then take that information and go off and generate a finite element model that for each of the individual components with all the details that you specified included, and then merge it into a final vehicle FIM. Kind of shown here in the bottom center. Is an example of like our XB15 model. And so moving on, once you have your FIM, it's important to note that this FIM is what we call optimization ready. So all of the analysis cards and details that are important to running an optimization routine are set up and constructed in a way that essentially are ready for immediate execution within Nastran. And I guess I'll point out just briefly that we do both support NX Nastran and MSC Nastran versions. But yeah, once you get to this step, essentially you're ready to run your optimization and size your vehicle structure subject to the load cases that you're interested in considering. Once your Nastran job is finished, you can run a post-process step, which is called weight, which allows you to generate a comprehensive weight statement. And essentially, this is a kind of a customized weight statement that we've created that breaks down not only all the individual component mass property information, but also the vehicle as well as other items that are interesting to report, such as CONM2s associated with attachments and things like that. And also we give a property summary. So when you construct all your properties for your vehicle, you can see what each property weighs, its thickness, what you had as like a baseline, and what the optimized thickness was to kind of give you very quick kind of informative feedback on whether or not your optimization went well and makes sense. And yeah, so that is essentially the workflow. So we have those six steps that finish at weight. And then moving on, I'm going to now discuss our capability summary. So this chart's a bit of an eye chart. I do kind of highlight now in four component blocks here. You can see the various capabilities of each component as you move through the workflow. And so I guess I'll give a little bit of a background on, prior versions of Structure Studio had the sketch point layout capabilities all done within OpenVSP. And now essentially you would basically just bring your VSP file once you're ready to start modeling the structure directly into our tool. You wouldn't need to do any sketch point layout creations within VSP anymore or use our customized version, because now all of those capabilities have been ported into our tool. And then moving on to Sketch, again, like I said before, this is where you really specify all the details. For material specifications, we have support for composite ply layup specifications, as well as rapid loads modeling. A lot of the work we've done in the past year or two now has been focused on rotorcraft features, adding additional rotorcraft features, thanks to support from NASA and Army Ames. And then in addition to that, we've also enabled a lot of viewing different visualizations that are within the GUI that I think Thomas will touch on a little bit in his talk. And then lastly, you can still run, execute, FIM, merge, and wait all from within the GUI. So kind of you can think we've really consolidated all of the capabilities into kind of a one-stop shop. Once you're done setting up your VSP model in VSP, all you have to do is save it and then just bring it right into our tool, and you're ready to start structural modeling. So then, lastly, I think I touched on some of these things already for FIM and merge and weight. I will point out for the FIM the types of analyses that we support: normal modes, linear statics, aeroelastic analysis, both static and dynamic flutter. Also, and obviously design optimization, which is what we're really after to get those size thicknesses for our vehicles. Okay, so I'll move on here and show kind of just some selected applications. The first one we'll start with is a conventional MD-87 vehicle that we looked at, and what you're seeing here is an animation where we're showing a trade between fuselage height and fuselage length, and we're kind of marching along the exterior of that design study envelope that we looked at, where each case that you're seeing here was generated with the tool and fully executed through Nastran with a sized optimized result to a given stress allowable that was specified for this vehicle. Our next application we'll show is a low boom vehicle that we looked at, and similarly this is another one where we did a walk around the envelope of looking at fuselage height versus fuselage length, and again each one of these are a fully sized optimization result from Nastran. Okay, so this result here is basically a flutter result that we're showing from an electric GA application. I believe this was shown last year. This was a really nice result where we did a sizing condition actually based on flutter, and so these types of things are possible with the tool and work pretty well. And then lastly here for the selected applications, just we've really looked at a lot of vehicles, many more that are even shown here. This is what we're allowed to show. As you can see on the left, we've looked at some VTOL UAM type style applications there in a previous phase 3 that concluded last year, and then we've also looked at kind of some traditional transports as well as GA and HAIL type vehicles. In the center there, you can see. And then on the right side, you can also see some missile rocket concepts as well as some blended wing RLV applications and even satellites, along with the Uber configurations there as well. So lots of different applications we've looked at with this tool set. Okay, so moving on to some of the recent developments. So we have been, I guess I'll point out first that we are working halfway through our CCRPP effort that was funded thanks with support to NASA, Langley Ames, and on Army Ames. And we've extended a number of different features and enhancements to the tool set, and we're still in the middle of doing that. Kind of the big feature that came out within the last year was our support for the Mac OS platform. We also have slated to look at Ubuntu next. And then moving on here, again, as I mentioned prior, there's a lot of enhancements to the UI. For any of you out there that have actually used the UI or looked at the UI in the past, you'll notice that it's been completely overhauled, shown there on the top right image. It has a lot of more streamlined functionality in it. As I mentioned, it can import VSP files directly. And then we have kind of a new and improved sketch point layout capability within this UI as well. And then many bug fixes. And then what else? Other additional demonstration cases we've been looking at. So the CH-47D shown there on the right, and the MV-22. And we're also looking at a structural increment for a rear ramp for that MV-22 configuration as well. We did have a presentation at AIAA Aviation back in the summer, and we did recently get a paper accepted into SciTech 2021 for those of you that are interested in learning more about our work. Okay, so for future work, just kind of a brief overview of that. So, as I mentioned, we're halfway through the CCRPP effort. We've got three more demonstrations that we're going to look at for structural increments, including the RVLT-B Hector there, shown on the bottom right. As I mentioned, support for Ubuntu platforms coming in the near future. And we're also working on a crashworthiness capability that will support our extension of rotorcraft features and integration with industry standard rotorcraft tools such as Ixgen, RCAS, and CAMRAD 2. The other thing that we're exploring is academic licensing options. We've been in discussion with a few professors at various universities and are hopefully exploring that option as well, and much more. All right, so with that, I think we've come to the next part of the talk here. So I guess we can roll to Thomas.
Yeah, Tyler. For I've got echo coming through there. That sounds like it's gone now. Someone has asked what you would recommend for system requirements in trying to run M4SS.
Yeah, so the system requirements, we have them somewhere. I don't have them handy at the moment to give you the exact details, but the requirements are not very high. Obviously, if on the software side, one of the big hurdles that a lot of folks have to overcome is the Nastran requirement. So I'll say that, or echo that again, is that you'll definitely need Nastran. But if your machine can run Nastran, you probably can run our tool. It's not excessively high on the requirements as far as that goes.
But it was originally Windows. Now it's Windows and Mac.
Right. Yeah, we support 64-bit Windows and Mac, and Ubuntu's coming soon. Is there any other questions?
Nope, you're good to go.
So Brandon, should I switch over so Thomas can take over?
Yeah, I think. Let's see. It's only about 20 after 3. I think we've got the questions in the live feed, and we're doing all right in social Q&A. For the time being, depending on how long you think it might take Thomas to get into his material, we can keep going. But as far as the UAM demonstration side of things, we'll try and start that right at 4 o'clock to stick on the schedule. So we can probably go ahead and just roll into Thomas's stuff now, and then we can pause sometime.
Okay, sounds good.
Hello, can you hear me? Okay, so let me try and share my screen. All right. So I think I'm going to be going over the sketch point layout tool and then the sketch tool within M4 Structure Studio. I think the plan was to start sketch at 4, but I think that'll probably be moved ahead at this point. But I'll just get into the sketch point layout tool now. Or should I start now? Or
you can just go ahead and start with the sketchpoint layout demonstration.
Right.
The way we have it blocked out at 4 o'clock is for the UAM demonstration. So it seemed like it. So would this be the beginning of that content, the UAM demonstration?
The beginning of that content was supposed to be M4SS sketch, which is like part 2 of my presentation.
Okay, yeah, so we can go ahead and start doing the layout demonstration, and then we'll start the sketch side of things at 4 o'clock.
Okay, sounds good. All right, so hello, my name's Thomas Nishenzi. I joined M4 back in January, and I've spent most of my time since then working on Structure Studio. So I'm going to be going over the parts of Structure Studio that are used to define the models, and as such require the bulk of the manual input. So first module I was going to talk about is the sketch point layout module, or SPL. So just as an overview, I'm going to be giving a brief overview of sketch point layout tool to begin with. Then I'll be talk about how OpenVSP models are imported into sketch point layout tool and how the sketch point layout tool uses them. Then I'll give an overview of what sketch point layouts are themselves, which is the core of the SPL module. I'll then go over some of the automated tools that are included in the sketch point layout tool. They make the tool a little easier to use for the user. Then I was going to go over how the sketch point layout tool is used to create the sketch model, which will be used in the sketch module of M4 Structure Studio. And then before I get into it, and then that the M4SS sketch overview will start at 4 o'clock, followed by the UAM demonstration. So here's kind of a 4-step process of using this tool. You start with the OpenVSP component. And this OpenVSP component is just built by the user before, it doesn't even have to be built with Structure Studio in mind. You can just have it ready. Then in the sketch point layout tool, sketch points are added to the OpenVSP vehicle. And that's what I'll be talking about during this session. Then after that, the sketch point layout is converted to the sketch model. In the sketch model, all the structural, aerodynamic, and load cases are defined. And then finally, that sketch model is used to automatically generate a Nastran-ready finite element model. So those of you familiar with M4 Structure Studios might be surprised that by the existence of this new module, this sketch point layout tool. Previously, M4 utilized a branch of OpenVSP called M4SS OpenVSP that contained its own sketch point layout tool. Although we enjoyed OpenVSP, we found maintaining the Structure Studio branch of OpenVSP to be cumbersome, and in the end, did not provide us exactly what we wanted from it. And what we really wanted was a streamlined tool solely for creating sketch point layouts. M4SS OpenVSP was not this, and more often than not, created complexity instead of simplifying things. So this brings us to the new M4SS sketch point layout tool. I'd like to say that this tool was made possible with the improved Python API of OpenVSP. Unfortunately, its development began before the API documentation became what it is today. So it was a little difficult on that front. And then at the bottom of the slide, we have a comparison of the discontinued OpenVSP branch with the new sketch point layout tool. As you can see, we tried to copy some of the look and feel of OpenVSP, but keep in mind that the sketch point layout tool is in no way a replacement of OpenVSP. It requires the user to import a pre-made model and contains only functionality related to placing sketch points. Some benefits we achieved by transitioning to the sketch point layout tool is that we unified all the functionality of Structure Studio into a single application, which streamlined the user experience. Additionally, Users can now simply use the latest version of OpenVSP as soon as it's released and not have to wait for us to update and build the M4 branch. So now that I've gone over this little history lesson, we can go into exactly what the sketchpoint layout tool is. So I'm going to start talking about importing OpenVSP models. So as I said, M4 Structure Studio utilizes the Python API of OpenVSP to import models. What this means is that Structure Studio has a direct access to the underlying shapes and parameters of the OpenVSP model. This would eliminate any model translation and healing that may be required by other tools. For example, some tools might require a step file. This would mean that OpenVSP first has to convert the model into step format, and then when that external tool reads the step file, it then converts it again into its own format. And this can sometimes require some form of geometry healing. So like I said before, M4 Structure Studio is able to utilize the OpenVSP model directly, eliminating any need for model healing or translation. So now that the OpenVSP model is inside Structure Studio, sketchpoint layouts can start being defined. So Structure Studio is used to predict structural weight. However, it isn't able to do that without any user import. It needs some information about the vehicle to make physics-based prediction. This information starts with the user-defined sketchpoint layout. Each structurally relevant component requires a sketchpoint layout, and each sketchpoint layout contains a single sketch plane and a list of sketch points. These layouts are used to locate structurally relevant points of interest on the OpenVSP model. Additionally, we provide the user with a limited access to the underlying OpenVSP model, such as tessellation parameters. So the first part of the sketch point layout is the sketch plane. I find the idea of the sketch plane to be a little abstract, but its goal is to simplify the process of defining 3D structural elements. So the sketch plane, or maybe you call it a modeling plane, is a 2D plane that when looked directly down, shows the full depth structure. For this wing example, I've defined the sketch plane as the XY plane. This allows the pattern of ribs and spars to be placed as shown, the red lines on a 2D representation of the wing. And when the time comes to generate the finite element model, it is able to define the structural layout of the 3D wing. So now then after the user has defined the sketch plane, they can start defining sketch points. Sketch points are placed directly on the OpenVSP model. Sketch points can be defined one of three ways. First is free points, which can be placed individually and placed anywhere on the component. Lines are defined with a start and end point, and any number of sketch points can be distributed between them. Finally, we have grids. Grids can contain any distribution of non-parallel or parallel rows and columns, and a sketch point is placed wherever a row and column intersect. Just as a further note on lines and grids is that they can be drawn straight in either parametric space defined in OpenVSP, or they can be defined as being straight in coordinate space. This just provides the user with an added layer of control and conveniences to the sketch point layout. So the sketch points themselves are the core of any model in Structure Studio, as they are we consider them the common building blocks of the model. Basically, all spatial, structural, and aerodynamic elements within Structure Studio are defined with the use of sketch points. I'll get into how they're used exactly in the sketch module of Structure Studio, but I've listed a couple of examples here. So like lines can be drawn between sketch points to define ribs and spars or bulkheads and floors. Triangles and quadrilaterals defined by sketch points can create skin boundaries and aerodynamic panels and control surface boundaries, while individual sketch points could be used to locate attachment points for non-structural masses and various other elements. One final thing to note about sketch points is that as they are defined as being on OpenVSP components, they will go along for the ride, so to speak, as OpenVSP parameters are modified. This allows Structure Studio to be used in design space exploration applications. So if the model changes, you won't have to go in and redefine all the sketch points. The sketch points are defined with their UW parameters, so they follow along. So now I'll go over some of the automated tools included in the sketch point layout tool. The first automated tool is the automated wing layout tool. The automated wing layout tool lets the user specify desired number of ribs and spars, and it automatically generates a corresponding sketch point layout. And if the resulting layout isn't quite what you want, you can go in and still edit the layout itself or add and remove sketch points. You can angle the ribs and spars as well. So the other automated tool we have is the automated fuselage layout tool. The automated fuselage layout tool lets you define the number of and parametric location of bulkheads and the number of axial stations between the bulkheads. Again, after the tool has been run, you can further go in and edit the sketch point layout to make it more what you want. So finally, once you've finished your sketch point layout, and you can use that sketch point layout to create a sketch model. So the sketch point layout models are converted to sketch models with the click of a button. It takes the 3D sketch points on the OpenVSP model and projects them onto the OpenVSP degen geometry corresponding to the sketch plane. And this creates a 2D representation of the model that will be used to define structures and load cases. The conversion process also automatically generates a basic structural model, and it includes a normal nodes analysis in the sketch model. So at this point, I think we're going to wait until 4 o'clock for the next section, where we'll go over sketch and the UAM demonstration.
Here, let me turn the mic on both. We had a question on the social Q&A that, let's see. Oh, no, that's already been answered. Okay, never mind then. Let's see. Anything in the live stream side? No.
We had a question earlier about the earlier structures, which I answered about the VSP stuff, but it was concerning interpolating aero loads and aero data from an aero mesh onto an FEA mesh, and about different techniques for that. And of course, the VSP, say VSP Aero-structures mesh is completely independent. I'm sorry, the VSP aerodynamics mesh is completely independent from the FEA structures mesh in VSP, but the Nastran tools that you guys are going to have tools to map aero loads to structures. So if you can, you might speak a little bit about what about that, or if it's going to be covered later, about how aero loads are mapped to the structural mesh in M4's tool.
Yeah, thanks, Rob. So since you're utilizing Nastran, for subsonic analysis, it has a doublet lattice capability inside of Nastran that we'll use, and that essentially within Structure Studio, how we connect the aero loads to the structural FEM is we have Nastran uses a spline, various spline capabilities for translating those loads to the FEM. And we have actually built in the M4SS sketch, you will be able to define those splines and the actual aerodynamic panel model itself within our tool in kind of an abstracted but similar to Nastran, because at the end of the day, that's obviously what's being created is the Nastran representation of that. So.
Thanks, Tyler.